The notion of a repeating block of code, or in other words a loop, is fundamental to just about every programming language. The Bourne shell does indeed support loops. In fact, it offers two different types of loops, what we call the while loop and the for loop. If you've ever programmed before in another programming language, say for example C, then you'll be very familiar with the notion of a while loop, and you'll probably be also familiar with the notion of a for loop, but the way the Bourne shell implements the for loop is actually somewhat different to what you might be used to. So if you were planning to skip over this chapter because you already know loops very well, I wouldn't skip over the module on the for loop. It is a little different to what you might expect. Also in this chapter we discuss the notion of arithmetic. We find out the way in which we can actually implement arithmetic using the shell. That's in the module on EXPR. Anyway, let's begin. We'll start with the while loop. If you're very comfortable with the if statement and the way it conditionally executes a block of code, then you'll probably be fairly comfortable with the while loop. It's very similar to the if statement. It actually just simply repeats the execution of a block of code in the same way that the if statement conditionally executes the block of code, in other words based on the exit status of one command at the top of the loop. And it looks like this. We start with the line while command, and that actually means while this command continues to return an exit status of 0, in other words true, then do the following. We have the word do on the next line, on a line by itself, and then we have the code block, which can of course be as many lines of code as you like, followed by the word done, which is a little inconsistent from the if statement, which actually just reverses the word if and calls it phi in the same way case becomes esac and so forth. And as I said before, the code block just simply executes repeatedly until the command at the top returns an exit status that is non-zero. Let's have a look at a little example of that. You might use the while loop to read an answer from the keyboard and keep reading the answer until they answer something that is valid. Or in other words, while they continue to answer an invalid answer, you get them to try again. So here we might read an answer, and then we use the test program to test whether the answer that they entered happens to be equal to the correct answer, which might in this case be chickens. And if it's not, then we can execute a code block which would echo out some kind of error message and ask them to do it again. I'll show you another example now. I'll demonstrate an example that's perhaps a little bit more useful. Here's a very simple implementation of the while loop that can be used to make sure that the user actually entered a valid directory name when a directory was required. You simply ask them to enter a directory and then you test it using of course the test program, the open square bracket, and if it is not a directory then you can print out an error message to that effect and ask them to enter that again, and that will keep going around and around and around and around in that loop until such time as they enter a valid directory name, at which point it will drop out to the bottom and echo out the word congratulations. Now the block of code between the do and the done may never get executed because the directory that they enter the very first time may actually be a directory. So let's have a look at that running. I'll run that now. Please enter the name of a directory. Well, I'll just type in some garbage there. Okay, that's not a directory. Please try again. And if I just press enter by itself, okay, so that's empty is not a directory. Please try again. I'll just type in /temp, and that is a directory. So that is clearly working. So there's really not much to the while loop. It's quite simple. If you understand the if statement, then you probably understand the while loop. It's actually simpler than the if statement because it doesn't have an else clause or an elif or anything like that. But there is actually one interesting, shall we say, advanced thing that you can do with the while loop, which I'll just show you now because it is very, very useful at times. It's actually possible to get a while loop to process each line of the output of a given command. In other words, to execute the code block once for each line of the output of the command. Let's have a look at an example of that. The command in this case might be the who command. So you can actually take the output of a program, like who, and pipe it to a while loop as long as the condition that you're testing in the while loop is actually a read statement. The read statement will continue to read one line at a time from the output of the who program until it reaches the end of the output, at which time it will return false. Now the data in the who program is comprised of 3 columns: the username, the terminal they're on, and the time that they logged in. So I can read the data from that line into 3 different variables: user, term, and time, and then I can simply echo that out. User has been on term since time, or I can process that in any way that I like. That is an extremely useful construct. It's a little bit difficult to get the syntax right and to remember how it goes, but if you can refer back to this, it's very, very useful. Okay, so that's it for the while loop. Pretty straightforward. There are 2 extra keywords in the shell programming language that are used to control the execution of a loop. And when I say a loop, I mean actually any kind of loop, not just the while loop. They can also be used in conjunction with the for loop. Those keywords are break and continue. So let's have a look at them. We'll firstly look at the break. Using the word break is a way to actually cause a loop to immediately terminate. Sometimes having a single termination condition at the beginning of a loop is not enough. Sometimes you need to have several termination conditions. There may be several situations in which you want to break out of a loop. So you can put the main one at the top of the loop, like while such and such is true, and then inside the loop you could have perhaps a series of if statements. If this situation is true, then break. In other words, terminate the loop. It's a very useful little option at our disposal. Continue is kind of the opposite. It will actually cause us to go around the loop again. In other words, any remaining code in the code block just simply gets skipped. We go around the loop one more time, and the loop condition right at the top of the loop, the while such and such is true, does in fact get retested. So the continue is simply a way of skipping a bunch of code, skipping the code that follows the continue line inside the code block of the loop. I think the best thing to do at this point is to have a look at an example. So let's do that. This block of code assumes that the user has just typed in some data into a variable called filename, and you can see that the last line of the loop is getting them to read another file name as well. So effectively we'll continue to go around this loop while the user continues to type something in response to the read command. So what does a loop actually do? Well, it assumes that the file name that they typed in is supposed to be a directory. So the very first thing that we do is we test to see whether it is, and if it's not a directory, then we simply continue, which means that we skip everything after the word continue all the way down to the done and go right back around to the while file name. Now the sharp people amongst you may see that we've actually got a bit of a problem here, because what we would want to do just before we continue is read the name of the next file name or the next directory name to test. Otherwise we're going to have an infinite loop, because we'll just go round and round the loop and we'll say while file name, and that will still be set. So we'll go and say, okay, is it a directory? And it still won't be a directory, and we'll just go around and keep doing those 2 tests over and over again, because the file name variable is not changing. So if you like, that's a little bug in this little code snippet. Nevertheless, the principle is correct, and the principle is that if it is not a directory, then simply skip whatever processing is involved next by use of the continue statement. So if we get past the continue statement, if we get to the fi and the next if, then we must have a directory at this point. So now we can do a little ls of that directory, pipe the results to wc-l, which will give us the number of files in that directory. Now we enclose all that in backwards quotes, so let's say there are 25 files in that directory. The backwards quotes and everything inside them gets substituted with the number 25, so we simply do a test if 25 is greater than 100, which in that case it wouldn't be, but if it was, if we ended up with 125, then maybe that's some termination condition, that's some error. If we ever get to a very, very large directory, then we stop processing altogether. So we would echo out a message to that effect: we are stopping, there was a huge directory, huge being contents greater than 100, and we break. We don't read any more information, we don't go around the loop again, we don't do any more testing, we just simply continue on with the next line of code after the word done, if there are any. So, assuming that we make it past the continue, which means that it is definitely a directory, and we make it past the break, which means it wasn't a huge directory, then we can process that directory as normal. So obviously there would be some code in there at that point that does whatever we need to do with this particular directory. So in general, I guess you could say that the continue is used to skip over invalid situations in a loop and make sure that we only process valid ones, while the break is used to terminate the loop altogether should some termination condition arise other than the one right at the very top of the loop. So that's about it. Break and continue. They're not actually that complicated, it's just a matter of getting used to them. In this module we explore the way that we can get the Bourne shell to actually do numerical calculations, or in other words, arithmetic. Now I did mention to you before that the Bourne shell actually has no notion of a number, which means of course that all the variables in the Bourne shell programming are strings. They're not integers or anything like that. Now because there's no notion of a number, there's no notion of a numerical calculation, at least not with the Bourne shell just by itself. There is actually another Unix program that we can use in conjunction with the Bourne shell called EXPR, which is designed to fill that gap, to provide the facility to do numerical calculations. And this is what it looks like. If you've got the dollar prompt up, your shell prompt, you can just type in EXPR and then your particular calculation that you're interested in. In this case, we would be multiplying 3 by 4, and EXPR would give the answer of 12. Let's have a brief look at that in action. So I could do, of course, EXPR 1 plus 2 and get an answer of 3. Now I could also do EXPR of, say, something like 3 times 4. Now I get a syntax error. Now why do I get a syntax error with that? Is it because I've used the wrong symbol for multiplication? Well, actually I haven't. The asterisk or the star symbol is in fact the correct symbol for multiplication. The problem is that the shell actually examines that line before EXPR ever gets a hold of it and notices the star there. So what it does is it uses that star as a wildcard and replaces that with the names of all the files in the current directory, which is not what we want. So in order to prevent it doing that, we can either put a backslash before it or we can put single quotes around it. And I'll just put a backslash before it because it's simpler. EXPR 3 times 4, and that gives us 12. Asterisk is actually the only one that we need to worry about. The minus sign and the plus and the divide by are all perfectly okay. And it's very important that you remember that you must have spaces around all of the arguments to EXPR. You cannot do this, EXPR 1 times 2, like that. You'll just get 1 times 2, which is not really what you want. And your arithmetic expressions can actually be quite complex, can be involved. You can even use brackets, of course, but brackets are another special character for use with the shell, so you'd have to put a backslash in front of any bracket that you used as well. So how does EXPR actually work in conjunction with variables? Well, it's not too much of a stretch of the imagination to come up with an example like this. Set a variable called a to be equal to 15, say, and set a variable called b to be equal to 3. Now, if we want to actually take 15 and divide it by 3 and then put the answer back into another variable called c, we can actually do that, but we have to put the EXPR expression inside back quotes. Let's go through that worked example in a live shell. What we'd really like to be able to do is just go a equals 15 and b equals 3, and what we'd like to be able to do is c equals, say, $A divided by $B, but you can't do that. We have to use EXPR in there as well, so we could say EXPR $A divided by $B, and that works fine, but that does not assign the value to the variable called c. It simply prints it on the screen. So if we want to assign it to the value of C, then we have to do it like this, put it inside back quotes, expr $A divided by $B, and this time we don't get any output at all, but it's fairly safe to assume that the variable called C has been assigned that value. Let's find out whether it has. Echo $C, and it is equal to 5, which is correct. So that's about all you need to know about EXPR. It's a very simple little program. There's a few little things you've got to watch out for, like the back quotes and the quotes around the asterisk or the backward slash or whatever it is. It does take a little bit of getting used to, especially if you're used to using another programming language that supports numerical calculations natively, but we don't have that luxury. So what I'd like to show you now is a simple way that you can use this EXPR program in conjunction with a loop. Because what we very often want to be able to do is cause a loop to repeat its code block a certain number of times. Like we might simply want to count up from 1 to 100 or something similar. And this is how you do that in the shell. Let's say we read in from the keyboard the maximum number of times we'd like to go around the loop, and so the user maybe enters 45. Then we set our loop counter to be equal to 1. And I've made a little mistake there on the screen. There's not supposed to be any spaces around that equal sign, but let's assume that I equals 1 there. And we now use the numerical facility built into the test program. Test is quite capable of comparing two numbers to see if one is greater than or equal to or less than the other one. So what we're essentially saying is here, while I is less than or equal to count, that's the minus LE is less than or equal to, then we can, I don't know, print out a message or anything like that. This is loop number I of count, so that might actually print out this is loop 1 of 45, this is loop 2 of 45, and so on. And then the key part of this whole code snippet that you're looking at is the next line, which essentially says I equals I plus 1, but we have to do it in a rather complex way. As we saw before, we have to use EXPR $I plus 1 with the space around the plus. We have to enclose the lot around inside back quotes, and then we assign that using no spaces around the equal sign to the value I. That might look like a complex way of doing a very simple thing, but that's exactly what we have to do in the shell if we want to loop a certain number of times. For those experienced programmers amongst you, you'd be probably used to using a for loop to achieve this effect, but in the shell the for loop is actually used for a completely different purpose, which we'll see next. We now come to the second type of loop offered by the shell, which is called the for loop. And as I mentioned before, this is actually unlike any for loop that you'll find in a regular programming language like C or Pascal or something like that. So let's have a look at how it works. The way the for loop works is it causes one variable to be set to a given sequence of values. That's the premise behind the for loop: set a variable to a given sequence of values and then execute the code block once for each value. And it looks like this. This is a little example. If you had a variable called var1 and you could set it to a range of values: bread, meat, dairy, vegetables, fruit, 5 different values there. And then you've got the do done, which surround the code block. The code block can of course be as many lines of code as you like. And then you can echo out one of the main food groups is, in this case, var1, which would be first time through the loop it would be bread, second time through it would be meat and dairy, and it would go through the loop exactly 5 times, and the 5th one would be fruit, and then it would finish. So it's actually a pretty simple construct. Notice the use of the word in there. I'll show you one very common use of the for loop. It's actually often used to run through a series of file names. And the reason for that is you can actually use wildcards to specify the different values that the variable might take. In this example here that I'm showing you, I'm using the asterisk. So the variable fname will take, in turn, one value that represents each of the star.txt files in the current directory. So if there are 10 txt files, then you'll go through the loop 10 times. If there's 1, then you'll go through it once, and if there are none, then you'll actually go through it once. and the value that you will have for fname as you go through will actually be star.txt. You might wonder why that is. It's not some feature of the for loop. That's what the shell does with its wildcard expansion if it can't find anything to match. It just leaves it as it is. So in this particular loop we are simply testing to see whether the file has a size, whether it is non-zero bytes in size, and if it is non-zero then we're going to copy it to theoretically a directory called backups. So that's pretty much it for the for loop. As you can see, it's just as simple as the while loop, but it works in a slightly different way. There are two simple exercises for this chapter. If you can complete both exercises, then you've probably got a fairly good grasp of looping in the shell scripts. The first is to create a script that examines all the files in the current directory and displays a total which represents the sum of the sizes of each file that contains the word foo. In other words, if you had 10 files in a directory, then it would look in each one for the word foo, and if it does contain the word foo, then it will take the size of that file and add it to an accumulated total, and right at the end of the program it will print out that total. The second exercise is the obvious addition to the course project. We simply need to modify the course project such that the main menu is displayed after each time they choose an option from the main menu, until the user types Q to quit. In other words, they'll go around and around and around the menu until they enter a Q, which is of course the way the course project ought to work. The menu should keep popping up. You shouldn't have to keep restarting the program if you want to see the main menu again. Okay, good luck, and as usual I will show you work solutions in the next module. Here are the solutions to the exercises in Chapter 6. Here's my solution to the very first exercise, the one involving searching for the word foo. Let's go through it. Well, the very first thing I do is I don't need to do this, but I set the pattern right up the top of the file so it's clear and obvious for people to find. If you need to search for a different pattern, it's quite easy to change the program. You just change it once at the very top. Then of course I have to set a size of 0. That will be what I accumulate my sizes into that variable, and it's vitally important that I initialize it to something. EXPR will have trouble with that if I don't. And now I use a simple for loop for f in star, so I examine every file in the current directory. Now some of them may be directories, so the very first thing that I actually have to check is that the file that I'm checking is a regular file. If it's not, then I simply continue. Now that line is not absolutely necessary. I could leave it out, and what would happen is if grep in the next line ever encountered a directory, then it would give us an error message, which would mean that I'd have to also redirect the standard error of grep to dev null as well. But I put that in for kind of neatness. I don't really like errors very much, and I'd also like to demonstrate the use of the word continue. So if we make it to the next line, which is here, then we must be working with regular files. It might actually be useful at some point to test whether the file is readable, but I'm going to assume that they all are. Now the easiest way to test whether a given file contains a given string of text is to use grep. And to save the actual results being displayed on the screen, then I simply redirect the output to /dev/null. Grep will return true or 0 if you like, if the file does contain the pattern that we're looking for. So if we do happen to find a file that contains the pattern, then we have to next obtain the size of the file. Now there are probably a couple of ways of doing that. The way I chose to do it is to cat the file and pipe the results wc-c. The -c option for wc counts the number of characters. So I enclose all of that in backwards quotes and assign that to a variable called size. And then next it's a very simple matter to use EXPR to add that size to the existing total and put the result back into total. So we're doing quite a few things here. We're using a for loop, we're using a continue statement, we're using EXPR, and we're using some other general clever techniques like redirecting grep output to dev null, using wc-c to obtain the size of a file, and so on. So let's see if it actually works. Let's do an ls-l in this directory, and we'll find that we actually have 4 files in this directory. Some of them will hopefully contain foo. I'm guessing that the foo loop program itself actually contains the word foo. So let's run it. Foo loop. Total size of all files containing foo is 800. Now I can tell you just off the top of my head that the file abc does contain the word foo, and contacts does not, and names.dat does not. So abc and foo loop were the only files that contained foo, and their sizes, as you can see, were 576 and 224, which indeed add up to 800. So the program seems to be working. Let's try it in a directory that does not contain the word foo, like the parent directory here. So we'll do chap06/foo loop. So run the foo loop program from the chapter 6 directory in this directory, and we get the total size is 0. So I'm guessing that that is in fact correct. Now let's have a look at the course project. So here we are in the contacts program, the course project. We'll notice here that the main addition is the adding of this line here, while true. Well, I often find that the simplest thing to actually do in a loop is create what I call a forever loop, which just loops and loops and loops, and somewhere inside the loop we can put a terminating condition, or we can continue, or whatever. As I demonstrate the rest of this sample solution, you'll see that this is actually a reasonably neat way of doing it, and I'm not saying that if you did it another way, using the regular sort of while input does not equal q technique is not a good way of doing it. That way usually works perfectly fine as well. It's just that I've chosen to show you the forever loop because it is a useful technique to occasionally resort to. Anyway, let's move on and have a look. All of this stuff is pretty much as before, display the menu, but now we actually, rather than just prompting them for an answer, we prompt them for an answer and we say or q to quit, and then we read the answer and process it as normally. But I'd like to do some special handling with empty answers. If they just press enter and don't type anything at all, then we'll just redisplay the menu, and it will be like they never typed anything at all. I'll show you that in a second. So we'll just continue if they type nothing, and then do the case statement as before, and 2 and 3 and 4 are all the same, but with the Q, and I've noticed that I've used Q star or Q star, capital Q star, because I want any line that begins with a lowercase or uppercase q to be counted as a Q to quit. I've actually covered all the bases there. Then we simply exit the program. Exit 0. 0 is our exit status, which is essentially a no error exit status. And then of course the other condition, please enter a number between 1 and 4. And we move on. Now finally, right at the bottom of the loop, because I clear the screen every time around the loop, I actually want to give them an opportunity to see the output of the option that they've chosen. So I just say hit enter to continue, and then read their enter. And of course, as soon as they read chunk, we go immediately back to the top of the loop and continue the loop, which will of course redisplay the menu. So let's see if it works. If I went through that too quickly, don't worry, because I've included this solution as usual on the CD for you to examine at your leisure. Let's now examine the solution working. And so let's first test the case where I type in nothing at all. I just press enter. Now you probably didn't even see that flicker, but I have pressed enter a couple of times so far, and it's just going right back around the loop again. Let's type in an invalid answer. Type in some rubbish. Please enter a number between 1 and 4 and press enter to continue. And around we go again. And I might type 5 this time again. An error message. Maybe one of the options that's not implemented yet. Search case is not implemented. Fine. Press enter to continue. So how about one that we have implemented? Now create records. Please enter the following contact details. Now I'll just enter some rubbish here. And notice I get the hit enter to continue again. And now I'm still back in the loop, ready to do more things like create another record or view a record. So let's do the view records selection, and here are the current contacts in the database, blah blah blah, there is one, and hit enter to continue, and around we go around the loop again. Okay, and so everything seems to be working, so I can now test to see whether we can exit the program by typing Q, and that worked as well. Excellent. So there is again a sample working solution to the specification of